NASA's James Webb Space Telescope is preparing for a deep space chemistry experiment. During the observatory's commissioning and ongoing mirror alignment, Webb's near-infrared spectrograph, NIRSpec, team successfully finished initial checkout and characterization of three mechanisms that are key for the instrument to do its work. The NIRSpec team will continue their commissioning efforts. The whole team is very much looking forward to the start of science observations this summer, several NIRSpec representatives wrote in a web blog post Thursday, March 3. Once operational, NIRSpec will split the light from targets that Webb observes into what scientists call spectra, measuring the amount of light with specific wavelengths. This fingerprint can teach astronomers about galaxies, exoplanets, and other objects, shedding light on properties such as mass, temperature, and chemical composition. With NIRSpec, Webb can take spectra of up to 100 galaxies at the same time, making observations much more efficient since collecting the light photons from such distant objects will take the observatory hundreds of hours. NIRSpec's three key mechanisms are a filter wheel assembly, a grating wheel assembly, and a refocus mechanism assembly, the Webb blog post stated. Here is how the instrument will work. The grating wheel spreads light from a target of interest into its colors, wavelengths, to make a spectrum. The filter will reduces contamination by blocking wavelengths outside of what scientists are interested in looking at. Then the refocus mechanism will adjust and sharpen NIRSpec's focus. Engineers checked out each of these assemblies separately, starting with the filter wheel assembly to make sure its 8 positions in forward and reverse directions are working. At each position, we recorded a set of reference data, NIRSpec officials wrote. This data showed us how well the wheel was moving, and how accurately it settled into each position. Between each position, we downloaded high-capacity buffer data from the positioning sensors, and the NIRSpec team analyzed the data. The data showed that the wheel moved very well even in the first attempt. Next, Webb engineers recorded the reference data of the grating wheel assembly and cycled the positions in much the same way, showing that everything was working correctly. Then with the refocus mechanism assembly, RMA, engineers also did an initial data collection before commanding the mechanism to move forward a few hundred steps from launch position, the blog post said. This GIF shows the before and after images from segment alignment, when the team corrected large positioning errors of its primary mirror segments and updated the alignment of the secondary mirror. After the initial move, the NIRSpec team added in the blog, we commanded the RMA mirrors to their previous best focus position. Successful completions of this test showed us that the RMA is a well-behaved and healthy mechanism. Advertisement. Amid the instrument checkout, Webb mirror alignment is continuing in its fourth phase, focusing on coarse phasing that measures and corrects small height differences between individual mirror segments, the blog post noted. The telescope remains in excellent health after its December 25 launch and has enough fuel for at least 20 years of operations.